All right, so you should have either a legal size piece of paper in front of you that looks like this, that has all of this information on it, or you should have this screen in front of you. And we're going to complete this paper together, or this screen together. So this is a graphic organizer to show you all of the things that we've been working on and how this information is organized. So everything is a relation. Everything fits inside this relation box. So I'm going to use the color blue, and I'm going to color blue all around the outside. Everything fits inside this blue relation box. Now we have some special kinds of relations, and those are called functions. So functions are just a special kind of relation. So I'm going to color this function box around the edge. So notice the function box fits inside the relation box, because all functions are relations, but not every relation is a function. And then we can classify our functions. Okay, and we've got this big box where we can classify our functions. I hope you guys do a better job than I do with your coloring. Alright, so we've got two kinds of functions we can classify our functions into, and that would be linear and nonlinear. So linear, we have linear functions, and then we've got nonlinear functions. Alright, now there's a special kind of linear function, and that is a proportional relationship, or some of you might call that a direct variation. So proportional relationships or direct variations, they are a special kind of linear relationship. All proportions there are going to be functions. If it's a line, most of your lines are going to be functions, and we have some nonlinear relationships that are also functions. Everything that is a function is a relation, but not all of our relations are going to be functions. So that's how this information, how this organizer works. Let's see if we can straighten this out a little bit down here. That's a little untidy. All right, now I'm going to zoom in super close on proportions here. Let's start there, because that's what you should be the most familiar with. So a proportion has a constant rate of change, and it is a single straight line through the origin. So something like that. All right, your equation is going to be something like y equals k times x, where k is your constant of proportionality. I'm going to abbreviate that as COP. I think most of you are familiar with that. You might also call that the slope, or you might have called that the rate of change. I'm going to abbreviate that as ROC. A verbal description of a proportion would be Earl saves $5 every week. There's no mention of a starting amount or an initial value. So if it's not mentioned, that initial value, which is your y-intercept, is 0. It doesn't mention that he has already saved up some money. So that initial value or your y-intercept will be 0, 0. So if I made this into an equation, it'd be y equals 5x. So 5 is going to be my constant of proportionality. If it's week 0, he has saved no money. Week 1, he saved $5. Week 2, he saved $10. Week 3, he saved $15. And week 4, Earl has saved $20. All right, finding the rate of change from a proportion, the fastest way to get there would be y divided by x. Will give you your constant of proportionality for a proportion. So 5 divided by 1, 10 divided by 2, 15 divided by 3, 20 divided by 4, all of those equal to 5. 5 is your constant of proportionality for this particular proportion. From there, let's take a look at linear functions just in general. Not necessarily proportional ones, but linear functions. So linear functions could look like all kinds of things as long as single straight line. Okay, so linear relationships, they have a constant rate of change also. Okay, and the constant rate of change is what causes it to be the single straight line. So let's say that my y-intercept is -1 and my slope is 2. So I repeat that slope of 2, and I'm going to come up with a single straight line. Let's say that my y-intercept was +3 and my slope here was -4. So when I repeatedly use that slope or that rate of change, that's how I get the straight line. Now what that looks like in an equation, and you guys are pretty familiar with this at this point, is y equals mx plus b if it's in slope-intercept form, with m being the slope or the rate of change and b being the y-intercept. Okay. Sometimes it's not in slope-intercept form. Sometimes we'll have a different form like standard form. So ax plus by equals c. And we rearrange that to be in slope-intercept form so we can graph it. Or identify our initial amount, which is our y-intercept. And the rate of change is our slope. Okay. So let's take this example, y equals 8 minus 3x. For this particular equation, y-intercept is 8, and the slope is -3. All right, so in a verbal description, there's so many options here. There will be an initial value of some sort. That's going to be your y-intercept. I'm going to abbreviate that as y-int. And then whatever your rate is, whether it's weekly, monthly, daily, hourly, if it's a rate of some sort, that's the slope. Okay, keywords to watch out for to find that slope and that rate: per, each, every. And then the examples that I was giving earlier, like daily, weekly, hourly, some sort of measurement like that. Monthly, yearly. Those are all some examples. That's not a comprehensive list. Those are just some words that will help you identify pretty quickly that it's talking about your rate. If I have a table 0 and 20, 10 and 40, 20 and 60, 30 and 80, and 60 and 140. Let's say we were testing this table to determine, is this table linear? Here's how you find your rate of change from a table. Find your y differences. Then find your x differences. And then write those as ratios. So I have 20s over 10. And I have that 3 different times. And then I have this weirdo down at the bottom, 60 over 30. Now I simplify both of those ratios. 20 divided by 10, 60 divided by 30. Both of those, reminder that it's the y difference over the x difference, both of those will simplify to my slope is 2. Now from this, I can write the equation for this table. My slope is 2, and if you look at this table, right here, that's our y-intercept. So y equals 2x plus 20. There's my linear function rule. Alright, so what you should have so far is linear and proportional. Okay? Next will be nonlinear.